Hi, today we're going to learn about systems of linear equations in two variables. So in this section, I will determine if a system of a linear equation in two variables are independent, inconsistent, or dependent. I will go over the substitution and elimination, which are two ways of solving systems of linear equations in two variables. Also, I will solve a word problem using two variables in a system of two equations. So before we get started, I want to just go over some of the graphs of a system of linear equations in two variables. So graph 1 over here. So graph 1 here, notice how they intersect at one point. They have a solution at 4, -2. So that means that it's consistent and independent. It's an independent system with one solution, and so basically they have different slopes. Yeah, they have different slopes. And they also have, different slopes and different y-intercepts. In equation 2, when the lines are parallel, they're inconsistent. They have no solutions. Lines have same slope, different y-intercepts, right? They have the same slopes, different y-intercepts. That's just how parallel lines are. Equation 3 is, notice there's only one graph, so it's like a graph that's overlapping the graph. So that means it's consistent dependent system. Notice how I said that they overlap. That means that they are many solutions. Lines have the same slope and they have the same y-intercept, so they're practically the same equation, right? So that means it's consistent, dependent, and then just has many solutions. So let's go to equation problems. So determine whether the given point is in the solution to the set to the given system. So this is really simple. All you got to do is plug it in to the original equation, right? And then you got to figure out if they both are true. So we got to put it in both equations, right? So I'll put it in the first one, -1 and comma 5. So it would be 2, -1 plus 5 equals 3. -2 plus 5. 5 minus 2 is 3, so 3 equals 3. That's true for that equation. Now we'll put it in the second equation. So that's -1 minus 2 comma y, which is 5, equals -9. So that's -2 times 5 is -10. Then there's a -1. So -1 minus 9. Is this true? No, because a -11 does not equal -9, so it's false. So no, it's not true. So let's say solve each system by expecting the graph of equation. So looking at that graph, they're both parallel. So what do we know about parallel lines? We know that they are inconsistent, no solution, right? Lines have the same slope but different y-intercepts. So yeah, if you need to go back to this, go ahead. Number 2. So we know it's inconsistent. It's an inconsistent system. There's no solution, right? Because they don't intersect. No solution. And lines have same slope. Same slope, different y-intercepts. that was easy. Solve each system by graphing. So there's there's two ways of graphing it. You could start at the y-intercept, which is at -3, and then go up 1, right 2. But I am. Oh wait, there's another part. 2x minus 4y equals 3. What I'm gonna do is because I'm really lazy, I'm gonna just figure out the x and y-intercept and then graph those points. Because I don't feel like solving for y and then doing the rise over run. I'm just gonna find the x-intercept and the y-intercept. So let's start with the top. What is our y-intercept for this equation? It's 0, -3, right? Because this is that's our b, and then our x-intercept. How do we figure that out? Remember, we solve for, you plug in 0 for y, so it's going to be, put it right here, 0 equals 1/2 x minus 3. Let's get rid of that 2 because it's a fraction, so it's still going to be 0, x minus 6 at 6. So x equals 6. So our x-intercept is 6, 0. What about this one? Let's find our y-intercept. So remember, to find the y-intercept, you plug in 0 for x, so I'm putting it right here. So wherever there's an x, you plug in 0, so it's going to be 2, 0 minus 4y equals 3. So that's 0, so that's negative 4y equals 3. Divide everything by negative 4. So y equals negative 3/4. So it's going to be 0, and negative 3/4 is about negative 0.75. So it's going to be negative 0.75. Let's find our x-intercept. Yeah, there's another way you can do it. You could just solve for y and then do the rise over run, but I don't want to do that because I'm lazy. Okay, so now let's find the x. So you plug in 0 for y, so it's going to be 2x minus 4, 0 equals 3. So that's just 2x equals 3. Divided by 2, divided by 2, so x equals 3/2, which is about 1.5. So 1.5, 0. Now we get to graph it. So, okay, so let's plot this part. So 0, -3 is right here. 2, 3. And then x-intercept is 6, 0. So it's 1, 2, 3, 4, 5, 6. And it's solid, so it's going to look... sorry for my graph, it isn't really perfect. So we'll call this y equals 1/2 x minus 3, because we got that from here, from this equation. And then let's plot this one. So negative 0.5 is right about here. It's really close to -1. And then 1.5 is about here. And as you can see, they are parallel. Yep, they are parallel. Okay, so this is going to be 2x minus 4y equals 3. So what do we know about parallel lines? We know that they are inconsistent. No, so that means they don't intersect, so that means there is no solution. And lines have the same slope. Same slope and different y-intercept. Yeah, you could have over here we could have just solved for y, and then they would probably have the same slope of 1/2, right? But I didn't do it because I was lazy, and I just found the x and y-intercept. Okay, good. So we're doing this one. Solve each system by substitution. Determine whether the system is independent, inconsistent, or dependent. And this is not, this problem is not finished yet. So it's 1/2 x minus 1/3 y equals 12. Yes, 1/2 x minus 1/3 y equals, this is not 3, this should be 12. And then we have 1/4 x minus 1/2 y equals 1. Yes. So we said we got to solve by substitution, right? So I got to solve for y. I got to solve for one of these to get y by itself. So I'll use this one to get y by itself. So I'll put, I'm gonna, let's see. I don't like this 4, right? I don't want, so I'm gonna multiply everything by 4. So that's x minus 4 times negative 1/2 is negative 2y equals 4. Subtract x. So you get negative 2y equals negative x plus 4, and then divided by everything by negative 2. Actually, I don't want to, hold on. I don't want to solve that for y. I want to, what I want to do is, I want to solve the first problem for y. I think that would be easier. So over here, let's multiply everything by 6. So I'll put this, we're going to put our work right here. So 6 times 1/2 is 3x. 6 minus 1/3 y, 6 times negative 1/3 y is minus 2y. And then 12 times 6 is 12 is 72. Subtract 3x. So you get negative 2y equals negative 3x plus 72 divided by negative 2. So y equals positive 3/2 x, positive 3/2 x minus 36. Now what we're going to do is substitute that into this one. Put this y into the second equation. So wherever there's a y, you plug in that. So it's going to be, put it right, 1/4 x minus 1/2, and then the y is 3/2 x minus 36 equals 1. So if you distribute this is going to be negative 3/4 x plus 18. Bring down this 1/4 x equals 1. And then what we're going to do is get rid of this 4 by multiplying both sides by 4. So you get x, oops, yes, you get 1, okay, so 1/4 x minus 3/4 x is negative. I need to simplify this before I multiply everything by 4. So this is going to be negative 2/4 x. I got to simplify before I get rid of the 4. Now I can get rid of the 4. I'm going to multiply this by 4, so I get 2x plus 18 times 4 is 18 times 4 is 72, equals 4 times 1 is 4. Good. So now we can subtract 72. So we get 2x equals 4 minus 72 is what? Negative 68 divided by 2 divided by 2. So we get x equals 34. Now what we can do is we could plug this x, into this equation. So y equals 3/2. Wherever there's an x, we're going to put 34 minus 36. So that's y equals 3/2 times 34 is 51 minus 36. So y equals 15. So our coordinate, our solution is 34, 15. So what does it mean when we have a solution? It means, remember, if we have a solution, only one solution, it's consistent and independent and has different slopes. So it's this graph. So yes, it's consistent and independent with one solution. So this is how you solve a system of equations in two variables with just substitution. The other one is elimination. So solve each system by addition. So we're and determine whether the system is independent, inconsistent, or dependent. So we got to do elimination. So what elimination is you're just getting rid of the x or y's, right? So over here, which one do you want to get rid of, the x or the y's? I want to get rid of the y's. So I'm going to multiply the top 5 by 5 and the bottom by 3. So we're going to multiply 5, the whole thing, the whole system, by 5. So this will be, I'll put it right here, 5 times 2x is 10x. 5 times 3y is plus 15y. 5 times 1 is 5. And then let's do the bottom. So 3 times 3x is 9x. 3 times negative 5 is negative 15y. And then 3 times negative 8 is negative 24. Okay, so the y's cancel, so you're left with, now we're just adding, right? combining like terms. So 10x plus 9x is 19x, and then 5 minus 24 is negative 19. Get rid of that 19, so we're going to divide everything by 19. So x equals negative 1. Now what you can do is you could put this x into the original first one, not the manipulated. So we'll put it in the first one. So it'll be 2, wherever you see an x is, you plug in negative 1. So 2 times negative 1 plus 3y equals 1. 2 times negative 1 is negative 2 plus 3y. Add 2, 3y equals 3 divided by 3. So y equals 1. So y value is positive 1. And then you have to put it back in the original equation to make sure they're both true. And I already done it, but if you didn't, go ahead and put it back. And we know it's true, so we have one solution, right? So if we have one solution, we know it's consistent and independent and one solution. And you write the solution as negative 1, negative 1, 1. There you go. Let's do 2 more. Classify each system as independent, inconsistent, or dependent without doing any work, without any written work. So we have to look at these. What do we know? Without so if you mentally, this one's okay. Like this is on the y. If we mentally solve for y for the first equation, I know it says don't do any work, but you gotta mentally do it. So if we get y by itself, we would get y equals 5x minus 6. I know it says don't do any work, but I guess you could mentally solve for y. Mentally solve the first equation by y. You would get this if you done it mentally. So we get y equals 5x minus 6, y equals 5x minus 6. They're practically the same equation, right? So what happens if we have the same equations? It's going to look something like this. They're going to overlap, and they're going to be consistent, dependent system with infinitely many solutions because they overlap, because they have the same slope and the same y-intercept. So that's what we know. So they are consistent, dependent system, infinitely many solutions, because they do overlap each other. Last one, and it's a word problem. Okay, so two-family income. Altia has a higher income than Vaughn, and their total income is $82,000. If their salaries differ by $16,000, what is the income of each? So we're going to have to develop some kind of system of equation with two variables. So we'll call it A. We'll let's label A as Altia, and then V as Vaughn. So they said that their total income is 82,000. So we can say A plus V is 82,000. Good. Now we just need another one, and it says if their salaries differ by 16,000, what is their income? So, and then it also says Althea has a higher income. So we could say Althea is made 16,000 more than Vaughn. So that's how you say 16,000 more than Vaughn, 16,000 plus V. And then you could just define Vaughn, you substitute into this equation. So it would be, we're plugging this equation into the first equation. So this is equation 1, and this is equation 2. So 2 into 1. So it will be A plus V. Oh, A is 16,000 plus V. So it would be 16,000 plus V. And then plus another V equals 82,000. So that would be 2V plus 16,000 equals 82,000. Subtract 16,000. So we're left with 2V equals 66,000. Divide everything by 2. So Vaughn is 33,000. Because we just solved for V. Now what would be Altia's? Altia is, the equation for Altia is 16,000 plus V. So it would be 16,000 plus V, which which we know is 33,000. So your total for Altia is 49,000. And if you add 49,000 plus 33,000, it should equal to 82,000. So that's how we know it's checked. It's true. And yes, 49,000 plus 33,000 equals 82,000. So we know our answer is true. Yep, and that wraps it up for this section. So if you like my video, please press like and subscribe. If you want a math video to be done, please comment below. Thanks.